Hello, this is Mrs. Poland for Algebra 2. In this video, we're going to factor trinomials where the leading coefficient is not equal to 1, and I'm going to use the split the middle technique and the trial and error technique. So look at the first problem. We notice that the trinomial is in standard form. We notice that there's no GCF. And we notice that the leading coefficient is not 1, it's 6. And so the first way I'm going to factor this is using trial and error. So with trial and error, what you're doing, it's really factoring is just reverse multiplication. So my goal is the first two terms should multiply out to 3x squared. Well, how can I do that? There are actually a couple of ways in this case. We can use 6 and 1, or we can use 2 and 3. For that first term, you don't have to look at the reverse. So typically, when the number is small in the middle, I would start off with the two numbers that are closer together. So I'm going to do 2x and 3x. I notice that the signs are going to be different in the parentheses because that last term has a negative in front, but we'll worry about that afterwards. The next thing I'm going to look at is the different possibilities for 20. We'll worry about the sign later. So what are the possibilities? You can do 1 and 20, but you can also do 20 and 1. You can do 2 and 10, or 10 and 2. You can do 4 and 5, or 5 and 4. And those are the only factors. Okay, so we have 1, 2, 3, 4, 5, 6. 6 combinations, and that's with 2 and 3. There are actually a lot more if you take into account the possibilities of 6 and 1. Okay. So are there any that we can eliminate? And there are. As I mentioned in class, you're never going to have a common multiple within the same parentheses as long as you factored out the GCF first. So what does that mean? You're not going to have 2 and 10 because 2 goes into 2. Likewise, you're not going to have 10 and 2 because 2 goes into 10. You're not going to have 20 and 1 because 2 goes into 20. You're not going to have 4 and 5 because 2 goes into 4. So really, the only ones you have to test out with the 2x and 3x combination is 1 and 20 and 5 and 4. Again, because that number in the middle is a small number, most likely it's not going to be 1 and 20. It may, and so you would find that out afterwards, but I would probably start with the 5 and the 4. Okay. So we're going to do 5 here and 4 here. Now, how am I going to tell with the signs and if this is correct? What you're going to do is you're going to find out the product of the inner and the product of the outer, and you're going to, in this case, take the difference because it's negative. So the product of the inner is 15x. The product of the outer is 8x. I know the signs have to be different, and I know since my middle term is a negative number, the larger number is going to get the negative. When I add down, negative 15x and 8x is negative 7x. So I know I placed the numbers incorrectly. So the 2x minus 5 is going to get the negative because the product has to be negative 15x. And likewise, the 8x has to be positive in that case. And therefore, that 4 is going to be positive. So your final answer using the trial and error technique is 2x minus 5, 3x plus 4. Now, this is a great technique, and I can see that some of you on last night's homework were really comfortable with this technique. Sometimes it's much, much faster, especially if you're dealing with like a prime leading coefficient, but sometimes people don't like it because if you don't guess right, you can go through a lot of tries. The more you do the trial and error technique, the faster you get at it. Okay, so now I'm going to go into method 2. Okay, so let me take out this pen, and this is method 2, the second method of that same problem. And in this case, I'm going to do split the middle. So with the split the middle technique, what you're doing is instead of saying the product is negative 20, you do the master product 6 times negative 20 to get negative 120. And the sum is really the negative 7. And you're looking for two factors that multiply out to negative 20 and add to negative 7. Sometimes people have problems figuring out all the possibilities, and so what you could do is you can go into the graphing calculator, GeoGebra, and you're going to type in, I have to do this differently since I'm using my home computer. So you're going to type in, let me hide this, negative 120, and you're dividing it by x. Okay, and then you hit enter. And you can't say anything in the graph because you have to zoom in. Okay, so we're zooming in, now we see the graph, and now I'm going to look at the table of values, and then probably we go negative 2 to 20. If you needed to do more, you could add more. And that gives you a list of all the factors of negative 120, and we're going to look to see which one gives you a sum of negative 7. And so let's list them out. I'm just going to go to this side and list them out. So 1 and 120, 2 and 60, 3 and 40, 4 and negative 4 and 30. We'll worry about the signs afterwards. 5 and 24, 6 and that looks like a terrible 6. 6 and negative 120, 8 and negative 15, and 10 and negative 12. Actually, we'll worry about the signs afterwards. The signs have to be different, and so because there's a minus before the negative 20, or here's the negative 20, and we want the sum to be negative. That means the larger number has to be negative. And now you want to see which difference gives you a difference of negative 7, and that's 8 and negative 15. So this becomes 6x squared minus, so we said 8x and negative 15x. So I'm going to do positive 8x first, but you could do the negative 15x first. You'll get the same answer. It doesn't matter. We're now going to group the first two and group the second two. When I group the first two, I get a GCF of 2x, and I'm left with 3x plus 4. For the second grouping, I have a common factor of 5, and I'm actually a negative 5. And when I factor it out, I get 3x plus 4. I have a common binomial of 3x plus 4, and I'm left with 2x minus 5. Notice that these two methods produce the same answer as expected, and it depends what you're more comfortable with. So I'm showing you both methods. You decide which one you like better. There are pros and cons to each. Okay, I'm going to do example 2, again with both methods. So I'm first going to do trial and error. And with trial and error, again, I'm thinking reverse multiplication. So how do I get 28? It could be 28 and 1. It could be 14 and 2. And it could be 4 and 7. And those are the only factors, and you don't have to worry about reversing them for the first term. Again, the middle term is not large, so I suspect that it's going to be 7x and 4x. I could be wrong. I might have guessed wrong, but that's what I suspect. My last term, it could be 1 and 12, but then it could also be 12 and 1. It could be 2 and 6, or 6 and 2, 3 and 4, or 4 and 3. And those are the only factors of 12. Then you say, well, I really want to cross some of them out because it's too much work. I know it can't be 1 and 12 because 4 goes into 12. It can't be 4 and 2 and 6 because 4 and 6 have a common factor of 2. It can't be 3 and 4 because 4 goes into 4. It can't be 6 and 2 because 2 is in common to 2 and 4. And so what are you left with testing out? 12 and 1 and 4 and 3. So let's go ahead and see if it works. I probably would guess that it's not 12 and 1 because that's a larger number, and that middle term that we're trying to find the product of the outer and the inner is a small number. So most likely isn't that, but it could be, but I suspect not. So I'm going to try 4 and 3. I know the signs in the parentheses have to be different because the last term is negative. And I make my nose and I make my smile. I have 16x and 21x, and because of that minus sign, I know I want to take the difference, and I want to end up with a positive value. So negative 16 plus 21 would give me that positive value. So that tells me that this 4 in the first parenthesis is negative, and this 3 has a positive, okay? Because that adds to 5x. So I just factored this, and now we're going to use, so this is the factor. Now I'll just write it on the side so it's easy to see. Now let's use the split the middle technique, so that's the second method. So I'm just rewriting the problem so it's easy for you to see. And with the split the middle technique, you're multiplying the first term times the last term, so 28 times negative 12. And when you enter that in the calculator, you get negative 336. That's the 8 times c. The middle term has to sum to 5. Well, I suspect that negative 336 has a large amount of factors, but let's check it out. So I'm going to clear what I have in GeoGebra now. And I'm going to start, and I'm going to type in negative 336 divided by what? Divided by x. Again, you can't see anything, so I'm going to try to change my window so I see the graph. Not that that's, you can get away with not doing that. And now we want to look at the table of values. And I'm going to go -2 to 20. And I have a listing of all the factors. Now remember, I want my sum to be 5, so the number has to be close together and the signs are different. So the first few are definitely not working because there's too big a difference. I only want a difference of 5. So I'm getting closer when I look at 12 and -28, but that's -16, so that doesn't work. 14 and -24 is -10, so we're getting closer. But when you see 6 and -21, that difference is -5. So let's go back to the document. We want it to be +5. So we know that 16 and 21, that difference is 5. We want it to be +5, so this 16 would be negative and the 21 would be positive. So now that we know the factors, you're going to separate the 5x into -16x, right, and 21x. You want to find GCF and GCF. What's in common to 28 and 16? 4x squared and x is x. And then in parentheses, that 28 divided by 4x is 7x. -16x divided by 4x is +4. Actually, it's -4. Sorry about that. Likewise, what's in common to 21 and 12? +3. And when I factor that out, you get 7x minus 4. I now see I have a common binomial of 7x minus 4, and I'm left with 4x plus 3. And that matches this other solution. I hope this video is helpful, and I'll see you tomorrow.